today we are going to discuss question number 8 and question number 9 from exercise number 1.3. So what the question number 8 is telling us? See, question number 8, find three different numbers, find three different irrational numbers between the rational numbers 5 by 7 and 9 by 11. So we need to find out three irrational numbers between two rational numbers which are given here. Okay, fine. Let's check out question number 8. Question number 8 is that two numbers which they have given us that are rational and that are 5 by 7 and 9 by 11. 5 by 7 and 9 by 11, and we just need to find out three irrational numbers between these two rational numbers. Okay, fine. So here procedure is that to find out irrational numbers between two rational numbers, first express them in decimal form, and once you have expressed both the numbers in decimal form, then you can easily find out an irrational numbers between that two rational numbers. So first we will express this 5 by 7 in what? 5 by 7 in decimal form. So I'll do here directly, you can do it in this procedure also. Here is how much? 5 and 7. So you can divide that 5 by 7. So first 5 is not divisible by 7, so we'll take here 0 point. It becomes 50. Okay. So here also you can do 0 point, and if a decimal point is added, it will become 50. So 7. Now we are going to divide 50 by 7. 7 sevens are 49. So 7 sevens are 49. Deduct it. We have left with only 1. No problem. Now 1 is not divisible by 7. Take 0. No problem. Now 7 ones are 7. Deduct it. We left with 3 only. Then it becomes 30. 7 fours are 28. Okay, no problem. So 28, we are going to deduct it. So we have left with only 2. Take one more 0. 7 twos are 14. 7 twos are 14. So we left with 6 as the remainder. Then it becomes 60. So 7 eights are 56. 7 eights are 56. No problem. We have left with 4. Okay, fine. So 4, that means 40. 7 fives are 35. 7 fives are 35 minus. And we left here with the remainder as 5. And from this 5, all digits are going to repeat. 7, 1, 4, 2, 8, 5. Because 5 and 5. So from here we were started 50. After that again you are going to divide this 50 by 7. So you will get 7 sevens are 49. Then again left 1. 1 becomes 0. Then 1 becomes 10. Then 7 ones are 7. 7 fours are 28. 7 twos are 14. 7 eights are 56. In that way you will continue. So this is your repeating block. 71, 42 and 85. 71, 42, 85. That will be your repeating block. This is your 5 by 7. So number 5 by 7 can be written in this form: 0.71, 42, 85, and the other number 9 by 11. 9 by 11 is equal to. Do this also. And similar way you can do. We'll do here. If you are perfect with the direct method, then no need to do that things. Okay. So 9 by 11 is here. 9 by 11. No, 9 is not divisible by 11, so 0 point, and it becomes 90. So 11 eights are 88. We have left with 2 only. Take 0. 11 ones are 11, becomes it, a reminder is 9, then it is 90. 11 eights are 88. Okay, fine, no problem. So since from here 9, we got the same reminder here, 9 9. So we are getting a repeating pattern. So minus 88, that means 2, 9, 11 eights are 88, no problem. 20, 11 ones are 11, 9. So from here it is going to repeat 81, 81, 81, 81, 81 and so on. So 9 by 11 is equal to 0.81 bar. Fine, no problem. So this is the answer of 9 by 11. 5 by 7 is equal to this, 71, 42, 85, and 9 by 11 is equal to 0.81 bar. Now students, we need to find out 3 irrational numbers between these two rational numbers. Now for that purpose, what we do, we just need to consider 2 digits after the decimal point in each number. 2 digits after the decimal point. So 71 and 81. You will consider 0.71, 0.81. Now irrational number first, n1, number 1 is equal to, you can write any number in between these two, 71, 82, 71, 81. I can write here suppose 0.720, 7200, 7200, and so on. Number second, you can write in this manner 0 point. Suppose I write here 80, 800, 8000, and so on. Third number, you can write 0.7532198777, but we are not going to repeat it. This pattern 7532198. So after 7 we will use another any number. So it will be suppose 4. Now here after 7 was 5 and here after 7 is 4. So it is not going to repeat. It's not going to repeat. And in this way you can continue. So that is your third irrational number. So you can write infinite number of irrational numbers in between these two rational numbers. Here we have written only 3 irrational numbers. Let's understand the procedure once again. They had given us 2 rational numbers and we need to find out 3 irrational numbers between given 2 rational numbers. So we just simplified that to 5 by 7 in this form. That means this is the repeating number, repeating type of rational number, means non-terminating recurring type of rational number, and this is again non-terminating and recurring. So which is the recurring block here? 71, 42, 85, and which is the recurring block here? It's 81. Okay, fine, no problem. Now see, we just used 2 digits after the decimal point, 2 digits after the decimal point to find the range of irrational numbers. So irrational numbers, as we know that decimal form of irrational number is non-repeating and non-terminating. So it's non-terminating, non-recurring. Non-terminating, non-recurring decimal form should be there. There only we can say that these 3 numbers are what? Irrational numbers. Irrational numbers. Okay, fine, no problem. Now the last question of this exercise is, see, the last question is telling us that classify the following numbers as rational or irrational numbers. Classify the following as rational and irrational numbers. Question number 9. Classify as rational and irrational numbers. Classify the following as rational and irrational numbers. Okay, fine, no problem. So the first number is given. I'll write all the numbers and we will discuss it. Number 1, it's under root 23. Number 2, it's under root 225. Number 3, it's 0.3796. 0.3796. Number fourth one, 7.478478. 7.478478. Okay. Number fifth one, it is like this: 1.10, 100, 100, and so on. So we are going to decide which are of them are rational and which are of them are irrational. Okay. So first understand, and I think you have understood all that things, what is rational and what is irrational. So in rational, its a decimal form is either terminating or non-terminating but recurring or repeating type. And in irrational numbers, the decimal form of irrational number is non-terminating, continue, and non-recurring, non-repeating. So no any digit is going to repeat, or no any group of digit is going to repeat in irrational numbers. Okay, fine. So with the help of same concept, we will divide these 5 numbers into rational and irrational. Okay, fine. So first one is root 23. Root 23. This is another type of irrational number. So the irrational number, the square root in which, if the number is there and that number is not complete square of any other number, then that is also going to become what? Irrational number. In any square root, if a number which is not perfect square, complete square of any other number, then that square root is also going to become what? Irrational number. So here, this is what type of number is this? This is a rational number. Okay, no problem. Root 225. Now square root is there, but the number which is inside the square root 225 is complete square of what? 15. 15 square is equal to 225. No problem. So the answer of this is 15, and hence this is not an irrational number. So sorry, I have written here wrong. I told you the correct thing, but while writing here did a mistake. So this is irrational number, and this is what? This is a rational number. It is not going to become irrational number because the term which is inside the square root, that is complete square of 15. Then this one is terminating one, and terminate, if the decimal form of any number is terminating, then that is obviously rational number. This is also terminating one, here ended, that's why it is also a rational number. Check out this: 0.10, 100, 1000, then 10000, and so on. So in that way it will continue. That means it is direct continue pattern is there. That's why it is what? Non-terminating one. Non-terminating, and no any number, no any digit or no any group of digit is going to repeat. That's why it is non-recurring. So non-terminating and non-recurring, that means it is an irrational number. That is also irrational number. So these are some numbers which we need to understand which of them are rational and which of them are irrational numbers. Okay, fine. So I think all of you have understood it very well. Okay, thank you.